This problem is about obtaining the Maxwell relations corresponding to the energy relations. The first one is obtaining the Maxwell relation corresponding to Helmholtz free energy. The another one corresponding to the internal energy change. This were asked in GATE Chemical Engineering in the year 2001 and 2007. Of course, out of these identities, you have to choose. These problems are quite common. Of course, this kind of Maxwell relations will be quite extensively used in chemical engineering. So, of course, they can be obtained from the fundamental derivations. I am going to explain you how to obtain them using a mnemonic diagram at the first, and also I will also explain about obtaining the relations by derivations. So we have this rectangular box and we have this line with arrowheads. This line is starting from the bottom corners and pointing towards the other corner and with arrowheads at the top. And I am going to write these thermodynamic variables starting from P, P, A, S, G, V, H, T, U. Erase simply pass G, V, H, T, U. So this P refers to the pressure, A, the Helmholtz free energy, S, the entropy, and G, the Gibbs free energy, V, volume, H, the enthalpy, T, temperature, U, the internal energy. So all the thermodynamic variables of importance are written here, and we need to obtain the fundamental energy relations and Maxwell relations from this mnemonic diagram. First, let us obtain the fundamental energy relations. First, I am going to write the relation corresponding to A, that is dA. dA. For writing this energy relations, first let us write the side variables. For A, the side variables are P and S. So we will write the side variables as such. So P and S are the side variables. For P, the distant variable is V. Otherwise, the side variable and distant variable are connected by these arrow lines. So for P, the distant variable is V. So distant variable is V. So to say about the distant, we will use this D. Actually, it is D is derivative. Still, for our mnemonic diagram, we will take this as distant variable. For P, the distant variable is V. So P and dV. Likewise, for S, the distant variable is T. So S, T, T. And since the arrows for P and S, for the side variable P and S, the arrowheads are pointing towards. So for whenever the arrowhead is pointing towards, we will have negative. So PdV, minus PdV and minus STT. We can understand this mnemonic diagram, the usage of mnemonic diagram with respect to another variable as well. So we'll write what is the this differential equation for U. du equal to, for U we have P and T as the side variables. So P and T first written. For P, the distant variable is V, and for T, the distant variable is S. So P dV and T ds. And for P, the variable is, arrowhead is pointing towards. So we have negative. Whenever the arrowhead is pointing towards that side variable, have the negative sign closer to them. So for T, there is no arrowhead nearby. So we have plus. Like using the same convention, we'll also write for the other variables, say like D, H. For H, the side variables are T and V. For t, the distant variable is s, so t ds. And for v, the distant variable is p, so v dp. Here, for both side variables, there is no arrow heads closer, otherwise the arrows are pointing away. So because of that, we have plus plus. The arrow is pointing towards, we'll have negative. Otherwise, for t and v, the arrows are not pointing towards. So we have plus plus. Fine. Likewise for g, dg equal to, for g we have v and s as the side variables. So v and s. For v we have p as the distant variable. So v dp. Sorry, v dp, and s we have dt. So s dt. And for s, the arrow is pointing towards. So we have vdp minus s dt. For v, arrow is pointing away. So we have positive. Fine. So thereby we have all these fundamental energy relations. Now we need to obtain the Maxwell relations corresponding to each and every energy relations. Let us see how to obtain the Maxwell relation corresponding to the dA. So for Maxwell relation for dA, that is the thing first we are going to do. For that we have, of course, we can make use of the same diagram here what we have already, pass GV HTU, and the lines with arrowheads pointing to the top. So we have this diagram. We are now going to obtain the Maxwell relation corresponding to A. Before that, let us again write this dA once more. dA, what is dA? dA for A, the side variables are P and S, and for P, the distant variable is V, so P dV, and for S, the distant variable is T, so S dt, and for both P and S, the arrows are pointing towards, so we have negative. Let us again check this. So already we have minus P dV, S minus S dt, the same thing we obtained. Okay, and now we are going to obtain the Maxwell relations corresponding to dA. For that we will add we'll add one more lines to this mnemonic diagram. So starting for this variable A, we are going to draw these lines. Likewise the other vertical and horizontal line. Starting from that A, for A we have this, just a structure we are making to hold this A, no? in such a way that we are making this vertical and horizontal, another vertical and horizontal. Okay, this is the thing. And now let us write how to get the Maxwell corresponding to A. So for that, dou P by dou T at V equal to dou S by dou V at T. So otherwise, dou P by dou T at V equal to dou S by dou V at T. See, dou P by dou T at V. So dou P, starting from this, dou P by dou T at V, in this line, dou P by dou T at V equal to dou S by dou V at T. And now this dou P by dou T is in one side and dou S by dou V is on the other side. Since we are connecting both the sides, these vertical lines, we can simply take the positive sign for both. Or simply dou P by dou T at V equal to dou S by dou V at T. This is fine. In the similar way, we will also write the Maxwell relations for du, which is also asked in this question. Okay, so the first one is corresponding to dA, and we have seen this dA. For the dA, we have dou p by dou t at v. Dou p by dou t at v equal to dou p by dou t at v. Dou p by dou t at v is equal to dou s by dou v at t. Dou p by dou t at v equal to dou s by dou v at t. Dou p by dou t at v equal to dou s by dou v at t. Dou p by dou t at v equal to dou s by dou v at t. So this is matching with the expression d. So d is the correct answer for the first question. The second one is obtaining the Maxwell relation corresponding to du. So let us now draw this same thing for or is one more diagram, or is we can even clear this. No? I will clear these lines. Fine. Now we are going to obtain the Maxwell relation corresponding to du. So what is du? From the mnemonic diagram, du equal to, for u the side variables are t and p. For p the distant variable is v. For t the distant variable is s, and for p the arrow is pointing towards, so minus. TDS minus PDV is the relation for du. Now we are going to obtain the Maxwell corresponding to du. So for doing that, so we are going to for this u, we are going to make a box like structure. Say for u, okay, and one more such line. Fine. So now these lines are going to help us. In what way? Dou t by dou v at s equal to dou p by dou s at v. Dou t by dou v at s equal to dou p by dou s at v. It's not complete. Say here these variables p and s are in the top and t and v are in the rest. These variables p and s are in the top and t and v are in the bottom. So we are connecting this top and bottom, so we'll have a negative. So whenever you connect this two vertical sides have positive, that's what is the case for dA. And whenever you connect this horizontal and top, bottom and top, whenever you connect the bottom and top, have a negative. Say which is this t and v are in the bottom, so t and v are in the bottom, whereas p and s are in the top. So whenever you have this, if you take this as p and this positive and negative, so you will be having positive and negative. Whereas for this p and t, no, this dou p by dou t at v equal to dou s by dou v at t. So both this p and t and s and v are in the two vertical sides. So two verticals will have of the same sign. Whereas when you connect this top and bottom have a negative. Say otherwise here this dou t or is tv are in the bottom and ps are in the top. Dou t by dou v at s equal to dou p by dou s at v, but this bottom and top, so we have this negative sign. Let us also, okay, let us first finalize this part now. So this dou t by dou v at s. So this corresponds to the option dou t by dou v at s equal to, so raise this for u, for du, dou t by dou v at s equal to dou p by dou s at v. Dou t by dou v at s equal to dou p by dou s at v, but of this positive and negative. So this answer option is A for the second question. Let us also obtain the Maxwell relations corresponding to, that is the energy relation and Maxwell relation corresponding to, of course energy relation corresponding to G and H we can obtain. First, since we have already obtained the energy relation of G and H here, we can write the Maxwell relation, try to obtain the Maxwell relation from this mnemonic diagram. So far, we'll just clear the diagram again. This we are going to obtain the Maxwell relation corresponding to the other two energy relations, namely dH and dG. So first let us do it for H. So H is here in the bottom. So make a box structure surrounding that. Fine, no? So we are making a box surrounding this H for dH. So we are, of course, what is the energy relation for dH? The dH equal to the side variable, yes, the side variables are T and V. For T, the distant variable is S, so TdS, and for V, the distant variable is P, so VdP, and both are pointing away, so we have positive. Okay, simply TdS plus VdP. So this is the energy relation. So for this, we are going to obtain the Maxwell relations. Okay, so what is the Maxwell relation corresponding to dH? Dou t by dou p at s equal to dou s by dou v, sorry, dou t by dou p at s equal to dou v by dou s at p. Otherwise, we are going upwards. Here also we should go upwards. So dou t by dou p at s equal to dou v by dou s at p. Otherwise, go in this line. So we'll write it here. So dou t by dou p at s equal to dou v by dou s at p. So again, simply we are connecting the two verticals. No? Otherwise, this TP are in the vertical, and S and V are also another vertical line. So since we are connecting two verticals, there is no negative sign coming. So this is valid. Likewise, we will also try to do for dG. Though it is a repetition, we will do it again for our clarity. For the understanding of this mnemonic diagrams usage, I will clear these lines again. We will do this for dG also. So let me clear these expressions. Fine. So I am going to obtain the relation for dG. dg. For g we have v and s as the side variables. For v the distant variable is p. For s the distant variable is t. And the arrow is pointing towards this s, so negative. Whereas for v it is not the case. So we have vdp minus sdt. Fine. So what is the Maxwell relation corresponding to dg? So for g is here. So we need to make a box surrounding this. So for g we are going to write the Maxwell. Fine. So these lines are drawn. So what is the Maxwell corresponding to dg? Dou s by dou p. Dou s by dou p, or is in the top line, no? Dou s by dou p at t. Dou s by dou p at t, no? Dou s by dou p at t equal to dou v by dou t at p. So dou s by dou p at t equal to dou v by dou t at p. Of course, here we are connecting this top and bottom. So whenever you connect this top and bottom, have a negative. Fine, no? So otherwise, this relation corresponds to the Maxwell of dg. So whenever you need a Maxwell corresponding to the energy relation, make a box-like structure which is capable of holding that variable that way. Say for example, for a, what we did, we made a box surrounding that. For u, we made a box surrounding here. For g, we are making a box this way. So by this way, we can obtain these energy relations and Maxwell relations by making use of this mnemonic diagram. Now, I'll also tell you how to obtain the relations from the fundamental derivations. So we are going to derive this derivation of energy relations. Okay, so from the first law, starting from first law, we have du equal to dq plus dw, and we will make use of these relations of reversible processes. For reversible process, we have dq equal to dds, and for tw we have minus pdv. So this is the what is the fundamental energy relation corresponding to u. And from the definition of H, what is H? H equal to u plus pv. So if you take a derivative, dh equal to du plus pdv plus vdp, and if you take this as 1, using 1 here, we have dh equal to tds minus pdv, or this is 2, using 2 in 1. Using 1 in 2, this du is replaced using this tds minus pdv, and already there is a pdv plus vdp. So pdv getting cancelled, so dh equal to tds plus vdp. And the definition of a equal to u minus ts. So dA, what is dA? Equal to du minus tds minus sdt. So du is equal to tds minus pdv, and here already that is tds minus sdt. So this tds and tds getting cancelled, so we have minus pdv minus sdt. That is the expression for dA. The same way you can also do it for g. So what is g? G equal to h minus ts. So dg equal to dh minus tds minus sdt, and dh is already tds plus VdP and minus TdS minus SDT from here. So TdS getting cancelled. So dg equal to VdP minus SDT. Okay, these relations are available, and we can obtain the Maxwell relations by making use of the exactness criteria applicable for the differential equation. Suppose you have a differential equation as a function of x comma y, and df will be written as dou f by dou x at constant y into dx plus dou f by dou y at constant x into dy. For this differential equation, this second derivative, otherwise if you take this as m and this as n, and for exact differential equation, that is, this is, if you take this as exact differential equation, for exact differential equation, this dou m by dou y at x, that is, the order of differentiation of the second derivative is not important. So dou m by dou y at x equal to dou n by dou x at y. So using this is what is called as exactness criteria. Using this exactness criteria, we can obtain the fundamental, we can obtain the Maxwell relations corresponding to each and every fundamental energy relation. Okay, that and all normally available in any books, so you can refer to them. Hope this explanation of this usage of mnemonic diagram is understandable. You can make use of this mnemonic diagram for obtaining always for solving any of your problems involving thermodynamic relations. Okay, thank you.